Hello friends, welcome to my channel. Let's have a look at a newly appeared problem. Problem 2435. Paths in matrix whose sum is divisible by k. In this video, we are going to share a solution based on three-dimensional dynamic programming. So first, I'll read through the statement of the problem, and then we will make some analysis and analogies. And finally, we explain the DP update rule during coding. First, let's look at the statement. So we are given a zero-indexed m by n integer matrix called grid and an integer k. So we are currently at position 0, 0, in other words, in the top left corner. And we would like to reach position m-1, n-1, in other words, the bottom right position. So the constraint is that we can only move downwards or right towards the right. So we are required to return the number of paths where the sum of the elements on the path is divisible by k. So since the answer might be very large, so we return this counting modulo a constant 10 to the power 9 plus 7. So here are three examples. So in example 1, the return is 2. So here are the two paths that satisfy the problem constraint. So in example 2, so this is actually very special. It contains only one row, so we can only move towards the right. And the elements are all zeros. So because 0 is divisible by any non-zero constant, so here the return is 1. So example 3 returns 10 such paths. So the constraints on this problem are the following. First, the number of rows and columns and their products, in other words, the total elements in the grid is bounded below by 1 and bounded above by 5 times 10 to the power 4. And the elements in the grid is non-negative and bounded above by 100. And the k is greater than or equal to 1 and less than or equal to 50. So with that said, we are ready to look at the problem analysis and coding. So before doing the coding, let me let me specify the method and make some connections. First, we're going to use dynamic programming. As we mentioned, the dynamic programming table will involve three indices, I, G, R. So here, I is the row index, G is the column index, and R is the path sum in the sense of modulo k. In other words, the range of R is greater than or equal to 0 and less than k. So this generic element is interpreted as the number of paths starting from position 0, 0 and ending at position ig, with path sum modulo k equals R. So notice that we are going to compute this n passes in the sense of modulo this constant. So next, we want to make some connections with other problem. First, so we observe that when k equals 1, so this problem is nothing special, but we count the number of passes from starting from the 0, 0 index and ending at m-1, n-1, because any integer is divisible by 1. So this is one observation I will see. Secondly, this problem is similar to Leetcode's problem 188, for which we could also address using three-dimensional DP. So please check out the corresponding video in our channel. So in fact, we feel that the problem logic here is more direct than that in problem 188. So that problem is best time to buy and sell stock for. So with that said, our plan is to explain the DP update rule during we're doing the coding. So let's go to the coding. So first, I'm going to initialize this, introduce a variable, so that we can easily modulo the constant. So actually this is important because in our first try, so we forgot to modulus capital M, so our return for some cases actually is not correct. So this is the one. And then another thing is the size of the grid, that is M and N, length of the grid, and the length of grid 0. So this is actually some preparation. So next we are going to set the DP table, which is a M by N by K table. So the table size, let's see, is M by N by K. So the initialization is actually interesting, right? So we are going to from outer to inside. So first we are going to set 0, then times K, right? So the last one. Then for a dummy index in range M, right? And then we make this as a N by K matrices. Then for this guy, we are going to make M copies. So this together will give us a M by N by K grid. So with that done, so we want to make some initializations. So here the initialization actually is for I equals 0, right? So in other words, the first row. So in the first row, we can only move to the right. So for this, we are going to track the path sum in the sense of modulo K. So for this, I'm going to set R to be 0. Then we are going to scan the first row, that is for J in range M. Then the R will be R plus grid 0J. Notice that we compute this in the sense of modulo K. Then we are going to set T0J corresponding R, that's to be 1. In other words, so we have a path with some R in the sense of modulo K. So this is one initialization. Another is for J equals 0. So in other words, we want to set the first column. So in the first column, we can only move downwards. So the corresponding DP table element is either 0 or 1. So let's fix that those for have a 1 value. So that is for let's set this R to be 0 again, and then for I in range M. So we're going to compute this one, R plus grid so I 0, the first column, then modulo K. Then we're going to set T I 0 R to be 1. So all those R's without this set will remain 0. So this is the initialization. Next, we're going to do DP update. So this is actually also very direct. So here we're going to set for I in range M. So we are going to 1 to M. So because we have set the first row. For J in range 1 to M. So first, let me record this grid value at index ij. So we want to find the number of passes ending at index ij. So this we are going to check for all the R's. So for R in range K. So we are going to compute the new R to be R plus value modulo K. In other words, the R is the previous path value modulo K. Then if we end at the current position, so the path sum will be this, right? Then how can we end at this ij? So there are two possibilities, right? So we can either from up downwards or from left to the right, right? So that's actually the so we can, so this is nothing but T I minus 1 J. So in other words, we arrive at ij from the above. So the previous path sum is R, right? So then we also we can from the same row but move to the right, that is G minus 1, so R. So here again we need to modulo this M. So this is a DP update. So what we are going to return finally is nothing but T at index M minus 1, N minus 1. This is the position, end position. And we want the path to have is a multiple of the given key. In other words, the remainder is 0. So we're going to, this is what we want to return. So with that done, actually this forms a full solution format for this problem. So let's do a check. It passes the first example. So now let's look at this example to digest. So this is for k equals 1. Actually, this is very simple because it corresponds to count the number of ways to arrive at the bottom right from the top left. So yeah. So with that done, let's do a generic case check. Yeah, it passes all the generic cases. So with that done, I guess that's about it for this specific problem. So it's good to check out the corresponding video for problem 188. That video is also using a 3-dimensional dynamic programming. So with that said, I guess that's it for this video. Thank you.